This video will demonstrate how to use the insert function to insert a new node into a doubly linked list. Hello, I'm James Helfrich. One of the most challenging parts of working with a linked list is managing the pointers. If you get a pointer messed up, you're going to lose nodes, have a memory leak, or crash. So oftentimes we use functions like insert and remove to help us with this operation. This video will demonstrate how the insert function works. We'll start with the basics. There are two types of linked lists, a singly linked list and a doubly linked list. The singly linked list has the data item and a pointer to the next node in the collection. The doubly linked list has a data item also, pointer to the next node and the previous node in the linked list. In other words, you can go forward and backwards with a doubly linked list and only forward in the singly linked list. We're going to use the doubly linked list for the rest of this video. So how do you insert a node into a doubly linked list? We're going to use the insert method with a t, the value we're going to push in, and the current node we're looking at, p current, and also a Boolean variable after, determine whether we're going to insert the new node after the current node or before the current node. So the first step is we're going to create a new node, and this is going to allocate a new node, and it's going to give both the next and the previous pointer, the new node, to the null pointer. Notice how I'm pointing at 4 right now in the collection. So I'm going to say p new equals new node, and I'm going to rely upon the non-default constructor for the node to set the value t, as well as set the next and previous pointer to the null pointer. The next, I'm going to direct the new nodes to the destination in the linked list. So I'm going to say p new arrow p next equals p current, and p new arrow p previous equals p current arrow p previous. And I'm only going to do this, of course, if p current is not the null pointer. Then I'm going to direct the destination linked list into the new node. So I'm going to have 2 point up to 3, and I'm going to have 4 point up to 3 as well. It's really important to hook up the new node first before inserting it to the rest of the linked list. Okay, let's take a look at how this works here. I'm going to have some code here where I'm going to first allocate a new node, p head, and it's going to give it the null pointer. Then I'm going to insert to p head 55. And this will create 55 with the next and previous pointer set to the null pointer. Now I'm going to insert 11 before 55. Notice how after is set to false. So this is going to happen in a 3-step process. First, I'm going to allocate the new node 11. Notice how next and previous for 11 are set to null pointer. Then I'm going to hook up 11's p previous is going to stay null pointer, but p next will be to 55. And then finally, I'm going to hook up p heads p previous to 11. And now 11 is fully integrated. Let's do the same thing with inserting 85. Notice how after is set to true. So I'm going to allocate a new node with next and previous set to null pointer. Then I'm going to hook up 85's new pointers. And now it's going to point to 55. And then finally, 55 is going to point up to 85. And now we're ready to go. Now I'm going to insert 28 before 55. So I'm going to allocate 28. Notice how next and previous pointers are set to null pointer. Then I'm going to hook up 28 pointers. And then finally, I'm going to hook up the rest of the linked list back to 55. Now I'm going to insert 67. Notice how after is set to true. And then I'm going to set 67's next and previous pointers. At this point in time, the linked list does not know anything about 67, but 67 knows everything about the linked list. And then finally, 55.p next is no longer going to be 85, it's going to be 67. And 85p previous is no longer going to be 55, but it'll be 67. Now all 5 nodes are fully integrated into the linked list. Notice how p head is not really pointing to the head anymore. So I'm going to say p head equals p head arrow p previous. And then p head equals p head equals p previous. And now my linked list is finished. Let's take a look at another example. So I'll have n, which is the null pointer, and then I'll insert 3, which is going to have a single node. Then I'll insert 6 after n, after 3, and then I'll insert 5 after 3, but notice how it's before 6. And then I'll insert 4, which is going to be before by default, before 3 arrow p next, which is going to be between 3 and 5. And then I'll insert 2 before 3, which is going to be 2, 3, 4, 5, 6. And now my list is complete. You can learn more about this by taking a look at the insert section of the linked list chapter of the C++ Data Structures textbook.